Okay, so here I was saying sp orbital. Sp hybridized carbon will only have one s orbital and one p orbital. That makes a maximum of two. Okay, that makes a maximum of two hybrid orbitals, and it is the hybrid orbitals that participate in bond formation. Therefore, the two are going to form sigma bonds. And then we are going to have the orbital that is going to two p orbitals that are going to remain unhybridized. These unhybridized p orbitals are going to bring about side overlaps, and from their side overlaps, they are going to form two pi bonds. So sp hybridized carbon should have two pi bonds and two sigma bonds. Okay, so this is what you're going to be looking at. These are the things that can help you. They will help you discover or identify. In short, they'll help you identify the different types of hybrid carbons that you can have in a molecule. So, having said that, we can now come to question 2 and look at the structures that we have. So they are saying identify each CC bond, CH bond, CN bond, and CO bond present in the following compounds, A and B, as pi bonds and sigma bonds. Okay, so you have to identify them either as pi bonds or sigma bonds, and then show the kind of orbital overlap, that is SPN, SP, SPM, SPN. So these SP, SPN, SP, this N should be represented by the hybrid type. So you're not going to write SPN when you are answering. You're going to write either SP3, SP2, and when it comes to SPM, SPN, you will write it's SP2, SP3, or SP3, SP3, SP2, SP2, and then the PP for the sigma bonds that form for each bond in G. So we're going to come and look at G, and then draw the molecular orbital diagram. So picture for compound H. Okay, so this one here, given here, and then label each CC bond in compound E, that one there, and arrange them in order of increasing bond length and in order of increasing bond energy. We are also going to look at that, and then draw the expanded Lewis structure for compounds A, E, and F. So A, E, and F. Anyway, we'll be going bit by bit and then answering like that. Okay, so we are dealing with structure A and B. So structure A and B for now. Identify each CCCH as a sigma or a pi bond. So I start with this one. What you're going to do is this CH3 here, you are not going to write it like that. So you're going to expand this structure, and the hydrogen atoms are going to be placed on the sides like that. So a bond goes up, a bond goes there, and a bond goes there. Then you put hydrogens. So rewrite this particular molecule so that the identifications become easy. And then here, where this ends, where these three lines end, where these two short lines end, where these two short lines end, there is a carbon atom. Okay, here, there is a what? A carbon atom. So this type of a presentation that you have is a bond line presentation. It's a bond line form of presenting an organic molecule. Organic molecules can be wrote in different ways. We can write them in short forms. We can write them as expanded forms. We can also write them in bond line formulae. So this is a bond line formula given here. What you should know is that whenever you have a bond and it ends like that, that will simply means where that bond is ending, there is a carbon atom. So this simply means here there is a carbon atom. So you have to rewrite this one since you are doing this organic chemistry for the first time and you need practice and stuff. So you are better off identifying this when written in expanded form. When it is written in the form in which it is written, it's a bit complex for starters. But if you can analyze it like that, well and good. So I'm doing this so that those of us that can have problems with this kind of structures can easily start identifying. So these 3 hydrogens, expand them, don't write them like this, write them 1 hydrogen there, the other one there, and the other one there, and here put a carbon. Then we start identifying. So all 3 hydrogen atoms that are bonded to carbon are sigma bonds. So what you're going to do is when you expand this one, on that side where you've expanded, you're going to put a C. I mean, a sigma symbol. This symbol, you're going to put it on. So is anyone writing what I'm trying to explain here? Has anyone written what I'm trying to explain? You take this bond up, this one, this side, this one. Okay, please share with us so that I can actually use your structure for,
Yes, sir.
for references. Can you share? Just switch your camera on. So this will help our friends that have not written to actually see what we are talking about. So gift, yes, given. You can show us what you've written.
Wow. So I don't know how to do it, but I've written.
Yeah, okay. Anyway, hopefully, okay, what I'm trying to still okay, I'll use, sorry, I can still use. So what I'm saying is these hydrogens that are here, show them like this. Come to structure G. Have you seen the way where my cursor is pointing? The way these carbons have been written like that. That is how you should write this side here. So this side should be written in this particular manner. The hydrogens should be shown like that for this end here. Okay, so for this end here, Katongo, you have started denting my board. Okay, so for this end of the carbon, show these 3 like this. And then here, put a carbon atom just. So you put a carbon atom, then the 3 bonds. Now, what I'm saying is this, between carbon and hydrogen like this, what you're going to do is get this, use this symbol and write it there. So write sigma there. Okay. So
so it means that carbon in the middle is bonded, is having a triple bond with nitrogen.
yes, that carbon in the middle has a triple bond with nitrogen. Okay, I've just remembered that PDF I'm using actually does okay, so what you're going to do is you will write a carbon like that. You're able to see this, right? The writing I've done there, you're able to see, right?
Yes.
Yeah.
Okay, so what I was saying is you're going to do this, that, and then you put hydrogen there, hydrogen here, and hydrogen there. Then to identify these bonds, what you're going to do is here, you write the symbol for sigma, like that. Even here, you put the symbol sigma. Even there on that bond, you put the symbol sigma. So you are telling us that these bonds are what? Sigma bonds. And then from there, you're going to come to carbon, carbon-carbon bond. The carbon-carbon bond there is also, since it is a single bond, it is also a what? A sigma bond. So you're going to put a sigma sign like that. And then carbon, nitrogen. There are 3 bonds here. Okay, so the middle part, you can call that as your sigma bond. So you can show the middle part with a sigma sign. Then the top part is a pi bond. You're going to show it as a pi bond like that. And then you also say, okay, the lower part is also pi. So you're going to show it as a pi bond like that. When you do this, what you've actually done is you've identified each of the bond that is present in this particular molecule. If you needed to do hybridization as well, you can check this carbon atom has how many sigma bonds? 1, 2, 3, 4. So this simply means that this particular carbon is sp3 hybridized. Okay, so this carbon is sp3 hybridized because it is able to form how many? 3 sigma bonds. And then this carbon here has 2 pi bonds and 1 sigma bond. Because it has 2 pi bonds and 1 sigma bond, that carbon there is sp hybridized. Remember, an sp hybrid is the only carbon, or is the only atom that is able to form 2 sigma bonds and 2 pi bonds. So the same is true with nitrogen. Nitrogen is also sp hybridized. So this is how you identify, but that is in instances where they ask you to tell us the hybrid that are in a molecule. But in this particular question, they didn't do that. So you only need to do that. You come to this one, you're going to do the same. For the carbons, you're going to, for the hydrogens, you're going to do that. You write your hydrogen there, you put your hydrogen there, as well as the third hydrogen there, like that. And then this is a sigma bond, this is a sigma bond, that there is a sigma bond. And this bond here is also sigma bond. And then carbon oxygen. Carbon oxygen bond, look at this, it's a double bond. Remember, a double bond is only formed by sp3 hybrid, and the double bond has 1 sigma bond and 1 pi bond. So say this is your pi bond. If this is your pi bond, then the other one there is your sigma. You can interchange this, it doesn't matter. There's no formula, there's no formality for which one is your sigma and which one is your pi. It's your choice. And then this is going to be your sigma. So you're going to do the same this side as you have done there. So you have identified the type of bonds that are in this particular molecule by doing that. Again, you can identify the type of hybrids that are there. This has how many? 1, 1, 2, 3. So it is like this one. So this carbon, as well as that carbon there, are sp3 hybridized. Why sp3 hybridized? Each one of these has 4 sigma bonds. And for there to be 4 sigma bonds, the molecule can only be sp3 hybridized. From there, you come to this carbon here. Check this carbon. What does it have? It has 3 sigma bonds, 1, 2, 3, and Y pi bond, meaning sp2. sp2, 1s and 2 orbitals combining to form a hybrid, and that hybrid is able to form 3 sigma bonds. So this carbon is therefore sp2 hybridized. The same is going to be true with this particular oxygen there. Because of the side overlap, this is sp2 hybridized. So that is how you are able to answer these ones. And it's good today that I've actually remembered to say, I'm able to do this, so that the learning will now become a bit interesting, because you'll be able to see these writings and what I'm trying to explain when I'm talking about the molecule and things like that, which is very good on our side. Yeah. So we'll continue from here tomorrow. It's already time. There's another class waiting. Yes, please. Yes, please.
Hello.
I'm getting you. Robert.
Yeah, yes.
Come closer to your mic, Robert. Sorry?
Oh,
Robert.
to show.
There's a lot of echo and we can't really get your question.
Okay, sir. Can you get me now?
Yeah, now I can get you clearly.
Yeah. Yes, I was saying that, for example, if you, in that case where we had a cabino,
Where we had the what?
you in that.
Robert, you are cutting. There was a time when you spoke and you came out clearly, and then when you start asking the question, you just go cutting like that.
Okay.
Maybe the network is bad.
What about this data?
What about what?
I'm saying that. Hello.
I'm getting you, Robert. When you're asking, when you're calling me out and stuff, you're coming clearly. But when it
Hello.
comes to the question, yes, Robert.
Yeah, yes, I was saying that in that case where we had the book, always necessary that we should identify the hybridization of oxygen, or it is automatically that we find the carbon. It is just the same with
I've heard you talk of oxygen's hybridization. What were you asking at the far end? You were cutting still?
So I think he's trying to
it
ask,
is always the same.
we're supposed to find
Yes, Robert. Robert, you can text me your question. I think I'll start with your question tomorrow, because there is another class that is actually waiting.